This roof beam has been holding up a building since before Columbus sailed to America. It's stronger today than the day it was installed. Meanwhile, the lumber you bought last month is already warping in your garage. Medieval builders weren't more skilled than modern carpenters. They understood something about wood that we threw away completely. And once you see what it was, you'll wonder why we ever stopped. Not all wood is equal, and medieval builders understood that at a level most modern contractors never think about. They didn't walk into a lumberyard and grab whatever was in stock. They managed entire woodlands, selecting specific trees over decades, sometimes over generations. Oak was the timber of choice across northern Europe, not because it was easy to work with, but because oak heartwood contains natural tannins and resins that resist rot, insects, and moisture. The heartwood of a mature oak is almost chemically hostile to the things that destroy wood, and medieval carpenters selected for it on purpose. The selection process didn't stop at species. Trees were felled in winter, when sap content was at its lowest. Less sap meant less sugar, and less sugar meant fewer microorganisms had anything to feed on once the wood was in place. Builders also favored trees grown on well-lit, north-facing slopes, where slower growth produced tighter, denser grain. Some research suggests felling timing went even further. German forestry studies have found that wood cut during the waning moon contains 4 to 5% less moisture than wood cut at other times, likely because the same gravitational pull that moves ocean tides also pulls sap down toward the roots during certain lunar phases. Whether or not medieval builders understood the mechanism, they followed the pattern closely enough that some guilds wrote felling dates directly into law. Once cut, the timber wasn't rushed into use. Medieval construction sites routinely stockpiled wood for years, sometimes decades, before a major project even began. Left to dry slowly and naturally, wood avoids the internal stress that comes from fast kiln drying. By the time a beam was finally installed, it had already done most of its shrinking and shifting. It was dimensionally stable. It already knew what it was going to do. That patience is part of why cathedral builders could fell trees their own grandchildren would be the ones to install, and why air-dried oak tests 20 to 30% stronger than kiln-dried oak of the same species and grade. Then there's how it was all held together. Medieval timber framing didn't use nails. It used joints. Mortise-and-tenon, dovetail scarf joints cut precisely enough that the pieces locked together through geometry alone. Wood moves. It expands when wet and contracts when dry. That's not a flaw. That's simply what wood does. And a nailed connection fights that movement constantly. The nail stays rigid while the wood shifts around it, and eventually something gives. A timber joint does the opposite. It moves with the wood instead of against it. In a well-cut frame, seasonal humidity can actually tighten certain joints over time, rather than loosen them. Some joints from the 1300s can't be separated with a crowbar today, not because of glue, but because the wood has spent centuries quietly squeezing itself together. That single difference changes how an entire structure behaves under stress. A timber frame spreads load across multiple joints instead of concentrating it on one rigid connection. If one joint shifts slightly, the rest of the system doesn't depend on it to hold everything up. Modern engineering has a term for this: redundancy. And it's expensive to design into contemporary buildings on purpose. Medieval builders got it for free, simply because they understood how their material behaved under load over centuries rather than years. The Stave churches of Norway make this concrete. Roughly 25 of them are still standing. The oldest, Ern's, was built around 1130, nearly 900 years ago, which means it has survived 900 winters, 900 freeze-thaw cycles, 900 years of snow pressing down on a wooden roof. Some researchers believe the carpenters who built these churches came directly out of Viking boat-building traditions, where understanding flex and load distribution under stress was a matter of survival at sea long before it became a matter of architecture on land. So why don't modern buildings last anywhere close to that? The honest answer is that they were never designed to. For many commercial projects today, the assumed design life is somewhere between 15 and 30 years. That's not an accident, it's the goal. Modern construction optimizes for cost per square foot and speed of delivery. Fast-growing plantation timber is softer and less dense than old-growth wood ever was. Engineered lumber, particle board plywood, laminated beams, is pressed together from chips and fibers using adhesives that respond badly to long-term moisture. None of these materials are weak by accident. They're cheap by design. The fasteners change too. Iron nails rust, and rust expands, splitting the wood around it and turning every nail hole into a channel straight into the timber's core. Modern framing, driven together by nail guns, lets you frame an entire house in a week, but speed comes with a trade-off. A nailed connection holds until it doesn't. Moisture swells a subfloor, thermal cycling works on a metal bracket for 30 years, and eventually something corrodes or loosens. Medieval joints had no metal to corrode in the first place, they simply got tighter with age instead of looser. Builders were just as deliberate about which part of the tree they used. A trunk contains two very different materials: pale sapwood near the outside and dense heartwood at the center. Packed with the tannins and resins, a tree spends decades building up as its own natural defense system. Medieval carpenters stripped away the sapwood before using timber structurally, even though that meant discarding 30 to 40% of every log. Heartwood resists decay roughly 5 times better than sapwood cut from the very same tree. Most modern sawmills don't bother making that distinction. They cut for board footage, not for how long the wood will last. What gets overlooked most is that these buildings weren't just constructed well once and left alone. They were maintained for centuries by people who understood the original logic behind them. Borgen's Stave Church has been renovated multiple times, and each renovation maps the replacement timber for species, grain, and moisture content, preserving the integrity of the original system. That chain of inherited knowledge, guild to apprentice, generation to generation, is arguably more fragile than the wood itself. The buildings have survived. The expertise to keep maintaining them correctly is what's actually at risk of disappearing. Some architects are circling back to all of this. Cross-laminated timber is having a real moment in commercial construction, and multi-story wooden buildings are going up across Europe and North America again, partly because the sustainability math is compelling. A forest regrows. A steel beam never will. Carbon stored in structural timber stays out of the atmosphere for as long as the building stands, so a structure designed to last 300 years stores that carbon for 300 years. The economics shift considerably once you start designing for centuries instead of decades. The uncomfortable truth is that we never actually lost the knowledge of how to build something that lasts. We just stopped choosing to use it. A carpenter standing inside Ernest Stave Church today is standing inside a structure that has already outlasted every building ever constructed in America. The gap between their construction and ours was never about technology. It was about what they were building for. The material, the structure, the people who'd be standing inside it 8 centuries later. We build for the delivery date and the budget line instead. Your grandchildren's grandchildren almost certainly won't live in the house going up on your street this year. So here's something worth sitting with. If a building put up today won't survive long enough for your own grandchildren to ever see it, what does that actually say about what we're building for? If this made you look at your own house a little differently, hit like. And let me know in the comments. Would you actually want to live in a house built to last 800 years, even if it meant waiting a decade longer just to move in?